Hello and welcome back to another Python tutorial. I know that in these days many European schools have started again, so before we dive into today's video, I would like to wish all the students who have recommenced their studies the best of luck, and I hope all of you have a wonderful year. With that, I would like to dedicate today's topic to all those students who are learning about dealing with functions. In particular, today we will discover how the Scipy library can help us perform key operations on functions, such as finding its roots, maxima or minima. So first things first, we can write import scipy.optimize as SO. Then we say import matplotlib.pyplot as PLT, and we'll see why this is in a second. Then we can say import numpy as, you guessed it, NP. And finally we can say from math import cos. Then we can define an equation called EQN, and we'll give it an argument x and say that we return, let's say, x plus cosine of x. Then we can employ the scipy.optimize subset of the Scipy library to calculate the roots of our function. We can do this by saying my root equals so.root of EQN, which is our equation, and then we have to give it a first guess as to what the root will be. For example, we can say 0. Then we can print myRoot.x, which will be the value of the root which the scipy.optimize library will calculate. Then, to make things complete and easier to see, we can represent the function that we've just written out. We can do this, of course, using the matplotlib.pyplot module and write x equals numpy.arange from, for example, -5 to 5.01 in 0.01 increments. Then y will be equal to EQN of I for I in x. And then we can write plt.figure to initialize our graph. Then plt.plot x, y. And then plt.plot, we can say -5 to 5, and then on the y-axis it will be 0, 0. This will give us a representation of our x-axis. And then finally we can say plt.grid and plt.show. Now, as you can see, if we run the code, we get that the root is -0.739, etc. And if we have a look at the graph we've produced, we can see that, yes, it seems about right. So let's zoom in even more, and you can see that indeed our root, which is the intersection point between our function and the x-axis, is approximately around 0.74, which gives us greater confidence that our result of -0.739 is right. Now, having seen how to calculate the root of our function, I said at the beginning that the Scipy module also lets us find the maxima and minima of an equation. We can start with the minima by defining a new equation, which is potentially easier to represent as well, and that can be x squared plus x plus 2. And then we will say that the minimum will be equal to so.minimize of EQN 0, where again EQN is our function and 0 is the first guess as to roughly where the minimum will be. Then we can say print minimum.x, as before, and the rest will be the same. We can again run our code, and this time it says that our minimum will be at approximately minus 0.5. I'm sure all of you recognize this equation as a parabola, and you can see that in fact our minimum, which is the lowest point, is indeed at minus 0.5. Finally, we can also calculate the maximum of our function. However, this is slightly different because the scipy.optimize module doesn't have a dedicated function which calculates the maximum. However, we can use some kind of sneaky technique to do this regardless. First of all, let's write out a different function, which can be, for example, minus x to the fourth power minus cosine of x plus x, for example, which is, in all fairness, quite a horrid function to calculate the maximum of. And then what we can do is we know that if we multiply a function by minus 1, we effectively flip it on its head. So calculating the minimum of this reverse function would allow us to calculate the position of the maximum in the original function. So, assuming that we want to calculate the maximum of this function, we can use the code we created before to calculate the minimum of the reverse of this function. And as we said before, this will yield the same result, namely the position of the maximum of the original function. In this case, we can also restrict our representation to minus 1 to 1. We also need to write a minus sign here so that our representation of our equation is correct in the graph. If we run our code, we can see that the position of our maximum is now calculated at 0.749, 0.75 if we round it up. And we can see, in fact, that this is exactly the case. If we zoom in, this is at exactly 0.75. This gives us confidence that the code we've just written is correct. So with that, let's recap. To calculate the root of an equation, we can use scipy.optimize.root. To calculate the minimum, we can use scipy.optimize.minimize. And finally, to calculate the maximum, all we have to do is calculate the minimum again, but of the reverse of our function. Now with that, you should be well armed for tackling even the most challenging functions, which would otherwise be difficult or even impossible to calculate by hand. As always, I invite you to check out my previous tutorials and put your skills to the test with my coding challenges. Also, please make sure to leave a like, as well as share and subscribe. I look forward to seeing you all again next week, and until next time, happy coding!